Okay, we are ready for 6.1, graphing exponential functions. So for it to be an exponential function, it has to look like y equals a number times some other number to the power of x. X is the exponent. X is a little number up top. If x is not the exponent, then it's not exponential. Okay, here, remember if we have an x squared, we know that that is quadratic. And if we just have an x like this, then we know that's linear. Okay. And then we can tell from the graph also. So the graph is L-shaped, it's either increasing or decreasing. If it is increasing, meaning it's going up, we say it's growth. If it's decreasing or going down, we say it's decay. Okay. Once again, the two that we've talked about previously, so these are examples of exponential, the ones that we talked about previously. This one right here is quadratic, because it's U-shaped, and this one is linear. It's a straight line. Now, exponential is always shaped kind of like an L, but it either starts and goes up quicker, or comes down quick and then levels off. Okay, and then we have from a table. We can also tell from a table whether or not this thing is exponential, linear, or quadratic. So here, it says x changes by a constant amount, and y changes by multiplication or division. So here, I'm going up 1, up 1, up 1. X is changing by a constant amount. But y is changing by multiplication. So this is times 2, times 2, times 2. Here, x is going up by a constant amount, plus 1, plus 1, plus 1. But over here, 3 to 1, 1 to 1/3, we're dividing by 3, dividing by 3, dividing by 3, and so on. Now, some non-examples, some ones that aren't exponential. This one you're adding 2 each time. So from here to here, it's plus 2. If you're going up at a constant, up or down at a constant rate like that, or adding or subtracting, that means that my change in y is steady. It's going to be linear. Okay. And then we also talked about quadratic, and there's a couple different ways to test for quadratic, and we'll get into that more later. But right now I want you to see how this one repeats. It goes 1 and then 0 and then back to 1. Even though the x values are not the same, that is what gives it that U shape. So that means that this one's quadratic. All right, let's look at an example. Okay, so this is growth. It's going up. This is exponential growth. We know it's exponential growth because it's increasing. It's going up. And this is exponential decay because as I go from left to right, it's going down. All right, and then we want to try one. It says use the table to graph the function and describe if it's exponential growth or decay. Okay, so we're going to start out, and we're going to plug a number in for x. Okay, well, I know anything to the 0 power is 1. If anything to the first power is that number. Then maybe I'll do 2. Well, 1/3 times 1/3 is 1/9. So let's try graphing just those points, and I'll show you how to make this table on your calculator in class. So 0, 1 is right here. 1, 1/3 would be like right here. And it gets increasingly closer to this line. Okay, so I really need something over here. So maybe I'll try -1. If I put -1 in here, that flips this over, which makes it 3. So negative 1, 1, 2, 3 gives me a good point. It means this thing goes like this. And since it's going down from left to right, it is decay. Okay, that's all there is to it. We're going to make tables, graph our points, decide if it's growth or if it's decay.